Hi, welcome to logarithms. Sometimes in the math world, we are presented with equations that look something like this. If you can see that, it says 250 times 0.2 to the t equals 100. Since we don't know what t is, we need a way to undo the exponentiation to get it t by itself. So we need to get this answer. How do you do that? The answer is logs. And we use logs by this definition. If y equals b to the x, then log base b y equals x. The way you say this is log base b y equals x. Now, what this tells you is that log base b of y is the function that tells you what power you need to raise b to in order to get y. Every exponential function has a corresponding log function with the same base. See, these are the same bases. To compute each logarithm of the form log base b u, ask yourself b to what power equals u. So, to practice this, let's try log base 2 of 8. So, we're trying to find to what degree or exponent is 2 raised in order to get 8. And this can easily be done without a calculator. You know your exponents. 2 to the third equals 8. Or, if you do need a calculator, well, we'll get to a lot later. So, now, this is all very interesting, but when we talk about logs, there are different kinds of logarithms, and the most common one that you'll come across is the common log, and that, by definition, is base 10. which means it's just log base 10 of x. And since it's a common log, it's the most used logarithm in the math world generally. We generally don't use 10, we just write log base x, because this implies that there is a base of 10. So change of base formula is especially important when you come across problems such as this. Log 5 of 13. That's not something you can just say, well, 5 to what is 13, because it's not a common, computation. 5 to what power is 13 is a bit difficult. So in order to put this into our calculator, which is what we have to do to figure it out, we can change this, rewrite it as log 13 over log 5. And the change of base formula is just that. Log b of x equals log of x divided by log of b. And notice that in this new change that we have here, this is log base 10 of 13 and log base 10 of 5. And we treat these as definite quantities, so not expressions. They can't be taken out, so these can't cancel and be 13 over 5. It's log base 13 equals some number, and log base 5 equals some number, and a number divided by a number, another number. But this number, not that number. So, moving quite along, the last thing is properties of logs. And this is more of when you're presented with a logarithm that is seen as an expression of multiplicity or division. So when you're presented with log base 5 of 2 times 3, we can rewrite this as log base 5 of 2 plus log base 5 of 3. And this will give you the same answer as if you were to compute log base 5 of 6. So, a similar property is that of division. 2 divided by 3 would be log base 5 of 2 minus log base 5 of 3. And again, this would be the same answer as if you had put in your calculator log base 5 of 6. So, another good rule to know is this. Log base 5 of 6 to the second equals 2 log 5 to the 6th. See, this is a good rule because we can bring this exponent down to the front, and that would be helpful in future problems that involve more work. Not necessarily, you wouldn't really do this with such simple numbers. But log, another property that's important to know is this one, which says that when you have a base raised to the same number, the log of that equals that number. So if we have log base 20 of 20 raised to the 43rd, that answer is going to be 43. Oh, I'm sorry, I mean U equals 8. Okay, and that is the logarithms.